You're listening to the Agentic Engineer Podcast, weekly AI agent intelligence for builders. I'm your host, and with me as always is my co-host. Let's get into it.
Issue 14. Anthropic's Glasswing partners found 10,000 critical vulnerabilities in 30 days using Mythos Preview. A paper proves coding agents collapse in convention-heavy frameworks. CodeGraph gives agents a pre-indexed knowledge graph and cuts costs 35%. And AI-generated issues are poisoning open source. Big week.
Quick rundown. Glasswing update. Mythos Preview found over 10,000 high and critical severity vulnerabilities across 50 partner organizations in 1 month. Cloudflare alone, 2,000 bugs for 100 critical.
CodeGraph. Pre-indexed knowledge graph for coding agents. 35% cheaper, 71% fewer tool calls, 57% fewer tokens. Tool of the week.
And a new paper quantifies why coding agents collapse in Django and Fast API, but succeed in Flask. Data layer defects are the #1 root cause. Convention over configuration is an anti-pattern for AI-assisted development. The big one. Glasswing update. Mythos Preview found 10,000 critical vulnerabilities in 1 month.
We covered Mythos finding a single curl vulnerability back in issue 12. That was the proof of concept. Now we have production numbers. And they're staggering.
50 Glasswing partners deployed Mythos Preview against critical infrastructure software for 30 days. The result, over 10,000 high and critical severity vulnerabilities discovered. Not theoretical, not in toy code bases, in the software that runs the internet.
Cloudflare found 2,000 bugs, 400 of them critical, with better than human false positive rates. Mozilla found 271 vulnerabilities in Firefox 150. That's 10x more than Opus 4.6 found in Firefox 148 just weeks earlier.
10x improvement in weeks. That's not incremental progress. Something fundamental changed in how Mythos reasons about code paths. The UK's AI Safety Institute confirms it's the first model to solve both their cyber ranges end-to-end.
Okay, I want to push back here. 10,000 vulnerabilities sounds terrifying. But how many of these are actually exploitable? There's a difference between a static analysis finding and a real attack vector.
Fair question. But the better-than-human false positive rate is the key detail. This isn't a scanner that flags everything. It's finding real bugs that human security researchers would find, just faster and at scale.
So the bottleneck has moved. Finding vulnerabilities is no longer the hard part.
Exactly. Patching them is. 10,000 critical vulns in 30 days means the remediation pipeline is now the constraint. Every security team using Mythos needs to triage faster than the model can discover. That's a completely new kind of problem.
And here's the uncomfortable part. Defenders now have a tool that finds 10,000 vulns in a month. Attackers will have equivalent tools soon. The window between AI finds the bug and AI exploits the bug is closing.
If you're shipping software that handles sensitive data, an AI will find your vulnerabilities. The only variable is whether you find them first. Mythos is currently restricted to Glasswing partners, but the capability exists. Assume every critical code base will be scanned by something this capable within 12 months.
Ship your patches faster. That's the takeaway. The era of security through obscurity is definitively over.
Quick hits. 5 stories. Rapid fire.
DeepSeek ReasonX. The cache-first coding agent. One user hit 435 million input tokens in a single day with a 99.82% cache hit rate. Paid $12 instead of $61.
The entire architecture is engineered around DeepSeek's byte-stable prefix cache mechanic. It keeps tokens cacheable across long sessions by design. DeepSeek only because the approach depends on their specific caching behavior. If you're running DeepSeek for coding, this is the cheapest way to do it. 564 points on Hacker News.
I love this because it's not a better model. It's better engineering around an existing model's economics. That's the kind of optimization that actually ships.
AWS Transform agents go multi-IDE. Hero, Claude Code, Cursor, Codex. All supported now via MCP server and agent plugins.
The numbers are wild. 4.5 billion lines of code transformed. 1.6 million hours saved. 1-year anniversary. plus a new agent builder toolkit in Kiro that lets you build custom transformation agents.
AWS is saying, we don't care which coding agent you use. We'll meet you where you are. That's the right strategy for a platform company.
Kiro breaks free. Web preview launched at appkiro.dev. Multi-repo coordination in a single session. Agents that open PRs and respond to review comments.
The standout feature is multi-repo coordination. One agent session working across your front-end, back-end, and infra repos simultaneously. Plus rewindable conversations where you can branch off any earlier turn. Workspace initialization is 88% faster.
Multi-repo is the feature everyone's been waiting for. Most real projects aren't one repo. They're 3 or 4. Having an agent that understands the full picture across all of them is a genuine unlock.
Forge, not the paper from last week. This is a Python reliability layer for self-hosted LLM tool calling. Takes an 8B model from single-digit success to 84%.
Rescue parsing, retry nudges, response validation. Works as a drop-in proxy server. Point open code or Claude code edit, and the client thinks it's talking to a smarter model. Sonnet 4.6 goes from 85 to 98%.
This is the reliability layer that makes small models actually usable for tool calling. Not an orchestrator, not a coding harness, just the part that makes things work. 685 points on ShowHN.
CLI anything. Making all software agent native. 40,000 stars. Plus 4,759 in 1 week.
HKU project that wraps any software in a CLI harness so AI agents can use it. Includes CLI Hub, a community registry for agent-ready CLIs. Recent additions, Recordbox, Calibre, Minimax. Works with Pi, OpenClaw, Cursor, Claude Code.
The thesis is bold. Tomorrow's software users will be agents, not humans. At 40K stars, the community agrees. This is infrastructure for the agent-native future.
Paper breakdown. Constraint decay. Why coding agents fail at real backend code.
This paper finally puts numbers on something every developer has felt. Your coding agent works great on simple Flask apps and falls apart the moment you point it at Django.
The setup. 80 greenfield tasks and 20 feature addition tasks across 8 frameworks. Flask, Fast API, Django, Express, Nest.js, Spring Boot, Rails, Laravel. Each task tested with increasing structural constraints from none to heavy. They measured assertion pass rate, not just does it run.
And the core finding?
Coding agents lose 30 points on assertion pass rates when structural constraints accumulate. They succeed in minimal frameworks and collapse in convention-heavy ones.
Give me the specific numbers. How bad is it?
Flask saw only a 7-point drop from 0 to heavy constraints. Django saw a 38-point drop. Fast API with SQL Alchemy, 31-point drop. The more opinions a framework has, the worse agents perform.
38 points. That's not a minor degradation. That's a different capability tier. Your agent goes from competent to broken just because you chose Django over Flask.
And the root cause is specific. Data layer defects, wrong ORM queries, violated database constraints, incorrect migration patterns. Agents understand the API layer fine. Business logic, fine. But the moment they need to respect an existing data model with foreign keys, indexes, and migration history, they fall apart.
So convention over configuration is literally an anti-pattern for AI-assisted development. That's a provocative claim.
The data supports it. If you're choosing a stack for agent-assisted development, pick minimal frameworks. Flask over Django, Express over Nest.js, or invest heavily in context engineering. Feed your agent the full schema, migration history, and architectural decisions before it writes a single line.
This connects directly to CodeGraph, our tool of the week. If the problem is agents not understanding structural context, the solution is giving them that context up front via a knowledge graph.
Exactly. The paper diagnoses the disease. CodeGraph is the treatment.
Time saved, 8-minute read versus 52-minute paper. 6.5x compression. Tool of the week. CodeGraph. Pre-indexed knowledge graph that gives coding agents a map of your codebase before they start reading files.
Here's the problem CodeGraph solves. The number one cost driver for coding agents is reading irrelevant files. Your agent greps, reads 50 files, finds the one function it needs, and you pay for all 50 files worth of tokens.
And it's not just cost. It's speed and accuracy. The more irrelevant context you feed a model, the worse its output gets. Needle in a haystack is a real problem.
CodeGraph indexes your codebase into a knowledge graph. Symbol relationships, call graphs, dependency chains. Your agent queries the graph for what calls this function or what depends on this module and gets precise answers. No more wandering.
What are the actual numbers?
Tested across 7 codebases in 7 languages. Average results: 35% cheaper, 57% fewer tokens, 46% faster, 71% fewer tool calls. The Tokyo benchmark, that's Rust's async runtime at 200,000 plus lines, hit 82% cost reduction.
82% cost reduction on a real, complex codebase. That's not incremental. That's a different economics entirely.
Install is straightforward. npm install-g CodeGraph. cd into your project. CodeGraph index. CodeGraph serve. It exposes an MCP server that any compatible agent can query. Claude Code, Codex, Cursor, OpenCode, Hermes agent. 0 config after indexing.
And this connects back to the paper. The constraint decay paper says agents fail because they don't understand structural context. CodeGraph gives them that structural context as a queryable graph. Instead of reading every file hoping to understand the architecture, the agent asks the graph and gets the answer immediately.
71% fewer tool calls means your agent finishes faster and cheaper on every task. For teams running agents on large code bases, this is probably the highest ROI tool you can add today.
23,809 stars, plus 18,136 in 1 week. That's the fastest growth we've ever tracked in the agent index. People are voting with their stars.
Agent Index Update. Weekly Star Tracker, May 27th.
OpenClaw at 374,509, plus 1,675. Slight cooldown from last week's 2,109, but still the undisputed leader.
N8N crosses 189K with plus 1,124. Strongest week since March. Workflow automation continues eating into pure agent territory.
Crew AI at plus 508 and LangGraph at plus 569. Still battling in the orchestration tier. LangGraph pulling ahead again.
The interesting signal this week. Semantic kernel at plus 45, nearly flat. Microsoft Agent Framework at plus 199. Microsoft's developer attention is clearly shifting from the SDK to the framework.
Mastra at plus 299. Fastest growing sub, 30K framework for the 3rd consecutive week. That's a trend, not a blip.
And LangChain at plus 585, while LangGraph gets plus 569. The graph abstraction is almost matching the parent framework in weekly growth. That tells you where the energy is.
Hot take. AI-generated issues are poisoning open source. And nobody's talking about it.
Armin Ronasher, the creator of Flask, published a piece this week on what he calls Slop issues. Bug reports that are 5% human observation, 95% AI-generated confident but wrong diagnosis.
And the problem isn't that they're AI written. The problem is they're plausible. They read like a senior developer wrote them. Detailed stack traces. Confident root cause analysis. Except the diagnosis is completely wrong.
Maintainers waste hours chasing phantom bugs. But here's where it gets worse for the agent ecosystem specifically.
Coding agents that read these issues inherit the wrong diagnosis.
Exactly. An agent reads an issue that says the bug is in the authentication middleware. The issue sounds authoritative. The agent goes and fixes the authentication middleware. Except the real bug was in the database connection pool. Now you have a wrong fix committed by an agent that trusted a wrong issue written by another agent.
A feedback loop. Agents generate bad issues. Other agents read those issues. Both produce wrong code. The signal-to-noise ratio in open-source issue trackers is degrading.
Ronasher's solution is interesting. Flask now has a /is command that tells agents to independently verify rather than trust issue text. Basically, don't believe the diagnosis. Reproduce the bug yourself. Form your own hypothesis.
That's good for Flask. But what about the other 2 million packages on NPM and PyPI that don't have this?
Every project with agent contributors needs something similar. Trust nothing. Verify everything. The era of the issue says X, so X must be true, is over.
I'll go further. This is a fundamental problem with how we've built coding agents. They're trained to be helpful and trusting. They read context and act on it. But open source issue trackers are now adversarial environments. Not intentionally adversarial. Accidentally adversarial. Which is almost worse because nobody's defending against it.
The uncomfortable truth. The more agents contribute to open source, the more they pollute the information environment that other agents rely on. We need agent-specific trust signals, verified reproduction steps, automated bisection, something that separates human-observed bugs from AI-hallucinated diagnoses.
And until we have that, the advice is simple. If your agent is reading GitHub issues as context, add a verification step. Don't let it trust the diagnosis. Make it reproduce the bug independently before attempting a fix.
That's a wrap for issue 14 of the Agentic Engineer Podcast. Subscribe to the newsletter at theagenticengineer.waltsoft.net and follow us on YouTube at the Agentic Engineer Pod. Share it with a friend who's building with agents. We'll be back next week. Until then, keep building.